Welcome back, part 25. In this video, we're going to look at trying to apply the motion data we read out in the last part, part 24, and see if we can use this to do kind of dynamic zooming and panning on the screen capture I'm recording that's put in my shorts. So go watch part 24 if none of that makes any sense, and then you can pick up here. So this is where we got to at the end of the last video. I have the motion data extracted, and Claude whipped out with extreme speed this kind of playback so we can visualize the data before we try and apply it to video, because this is way quicker to look at than doing a kind of render, waiting for that, and then finding out, oh, that wasn't wrong. So what we're going to do in this video is write a couple of algorithms with Claude that processes this movement data and tries to get it in a simpler format that we can then pass to FFmpeg for when it renders the shorts, if that makes sense. So what you're seeing on screen is boxes around areas of motion. Now, one thing I didn't realize when we got this at the end of the last video, and I was very excited about, is there's a slight problem with this. This is actually two separate videos, because of course the way I'm capturing video are these OBS recordings that put my webcam on the left and my screen share on the right. So of course most of the motion is on the left. So this area is me. This motion is me moving like I'm doing now. It's picking up my hands, my face moving. And you can see there's not as much motion on the right. And on this view, this kind of freaked me out a bit, because I thought, wow, there's no motion being picked up. But what I did was I reprocessed the extracted screen capture video that the pipeline already processes and got just that side out. So this is the same thing, but this is just a screen capture, because we're not really concerned about me. There may be some kind of use case I haven't thought of. Maybe I'll ask Claude for some ideas. But this is the data for the screen recordings. So this is going to be a combination, and especially on the video I've used to do this, this is going to be a combination of me using VS Code. So code in the middle, couple of panels on the left and right, the Claude chat, the file explorer that I would be scrolling up and down, and I use the UI for this whole process, and I'm scrolling up and down now. And I think you can tell the part in the video where I'm doing that, because if you look at these blocks, I can tell which parts this. There you go. That was me scrolling up and down in the middle, and it's detecting which words and things are moving. Now, this may still not be good enough to work with as data, and so what I'm thinking is we may have to increase the amount of frames that are sampled, but we'll see how we go. So, what we're going to do is write a couple of algorithms to kind of smooth this data out. So I've already written all the prompts for this, and we'll see what we get. So the way I'm thinking about doing this is the code that extracts the frames. I'm going to ask Claude to add a new function to it that will run over this data before it's saved to disk. Because by doing that, I can then just reapply this motion replay report, and we'll see the effect of what that algorithm does as it extracts the data. It would be quicker to probably write it standalone, but this actually doesn't take too long to run, so we'll roll with this. I've written a few prompts of this, and I've written the prompts all the way up to actually getting this used in the video. So assuming nothing goes badly wrong, we should be able to rattle through each of these prompts I've written and see what they do and whether they work. So that's the plan. Where am I prompts. So let's start at the top. So I'm calling this data smoothing part 1. So the motion detection script is successfully extracting motion data from videos and saving this to disk. I want to establish a function, normalize motion data, that processes this data before it is saved to disk. Create the function, then apply the following treatments in it. For each motion event, exclude any regions where the width or height take up over 80% of the total video's width or 80% of the video's height, respectively. And then the opposite value, height for width, width for height, is less than 10% of the original value. This is going to sound confusing, but the next line explains it. This is to exclude long, thin regions that span nearly the whole width or height of the screen. So that's like scroll bars. So if we get a scroll bar, a vertical scroll bar especially, that uses so much height where the actual thing that's moving might just be small. We want to kind of exclude that and just try and coerce the data to not necessarily the smallest area, but the main area that's moving. Make this a sub-function of the normalize motion data function. I'll explain that in a second. Second treatment, find the minimum X and Y value and the maximum width and height value within the regions array, and replace all regions with a single region entry of these values. So what is that going to do? If you look at the playback here, I'm not interested in all of these boxes where you're seeing multiple boxes per frame. What we're interested in is the minimum X value. So that's here. That's like where it is on the left. We're interested in the minimum Y value, which I believe will be the top, and then the maximum width and the maximum height. So effectively, I'm asking it to give me the coordinates of a bounding rectangle that would go around all the red boxes. So what that will do is reduce all these red boxes we're seeing, where we see more than one, to one single box per frame. So that's what that step's going to do. It's going to normalize all those boxes into one big rounding box. That's effectively saying all the motion is within that box. So the first treatment, it's important to have that in there so that that big bounding rocks wouldn't include a scroll bar that would make it a massive bounding box, if that makes sense. And then again, make this a sub-function of the normalized function, normalized motion data function. So you're going to have one function that processes the data, and then I'm expecting two functions within it. Why do I want to do that? Because if one doesn't work, I may want to comment it out and run this again just with the other one, although the second one is kind of dependent on the first. So this is prompt number 1. So I'm not going to put this in plan mode. I am just going to say, go do it. Okay. I had a couple of different ideas about how to approach this video because I almost thought about, should I just take every single prompt I've written here and go, hey, this is my idea. Claude, do you understand what I'm trying to do? You got any better ideas? And I may still do that because it will be interesting to see how much smarter AI is than how I've thought about this. And I'm sure it will come up with something. But I kind of want to work through this for myself just to understand whether the approach will work. And then we'll see what Claude can do later, maybe. So you can see it has not mucked around. It's done this. This isn't a particularly complex algorithm. So filter thin regions, there you go, width height 80%. What's it doing? Filtered R. So that's just getting that's going to return the data minus those breaching regions. And then merge to bounding region is going to get all those separate boxes, get the max X, Y, height, width, and just return the one box, which is what that's doing. So I can already read that. And then it's looping over the whole lot. And then, yes, exactly what I asked for. We've got, hang on a minute, merge to bounding regions, filter through regions. So, yeah, so it's given those as separate functions. So I'll have to, like if I wanted to comment that out, I'd just have to set regions to event regions, merge to bounding regions. I can just comment out if I want to remove that. And then, so let it make the edits. Now wire it in before saving. Done, here's what was added. Don't need to read this explanation. It's exactly what I asked for. And that should be changed. And then it calls it there. So I'm going to rerun the motion detection. Okay, that's completed, 20 seconds. And then I need to run the visualize script again to spit that out. Let's see what we've got. Give this a refresh. And this will have either failed spectacularly. Yeah, so it's definitely done the bounding. So you can see there's no more multiple boxes anymore. So in theory, when you're looking at this, what you can imagine is there's discrete areas here that this would zoom in on. You're starting to get a sense of, okay, what's this going to do in terms of where it's going to zoom and pan? What I'm really liking when I'm looking at this is I'm seeing some of the bigger areas, because I want to know that this is going to do a fair bit of zooming out. Remembering this is only going to apply to shorts, and we're also seeing some of these smaller areas, which means it will zoom into those. What we will do is have a minimum, I guess a maximum zoom or a constraint, like some of the really tiny boxes. I'm going to be like, no, don't zoom into those. But honestly, I don't think that will be a problem because of what we're going to do in the next problem. So step one, all good. This one's interesting. So that to me is exactly the kind of thing I wanted to kind of exclude. I'm not going to worry about it for now. So this kind of thing, I mean, that's not 80%. That's more like more around the 70% region, the 70% of width, and it's very narrow. So it was exactly that type of thing I wanted to strip out that would have been kind of 80%. So that's 70%. So again, it's working. It's done what I asked. Let's move to prompt 2. What I might do is check that in because that's working. Data smoothing, part 1. This is a bit technical, but if you follow along with this, there could be something pretty special at the end of this, if it works. Prompt 2. Okay. This one's more complicated. Implement a new subfunction in normalized motion data. So asked it for 2, I now want a 3rd. This will smooth the noisy motion data and generate more stable bounding rectangles that encompass motion over a longer period of frames. This should loop each motion event, sample frames, and keep a sliding window, I need to change that, it's not going to be a sliding window, of collected region data that will be processed as follows. Let me just correct that. So sliding window is a algorithm. You loop data and you keep like an array of data that you just want to compare and do things against as you move through the whole array. It's an efficient way to not loop a long array of data twice. But this isn't actually going to be a sliding window. This is more going to be like a buffer. I might write buffer, that's probably a better term, of collected region data that will be processed as follows. 1. Push each frame's region coordinates into a separate array buffer of collected region values and the motion events array index. What the hell does that mean? So if we look at the data, it's going to go through and it's going to go, okay, first entry, I need to get the region data and the frame number and put that in the array. Then I'm going to go to the next frame and do the same thing. So this buffer is going to start accumulating arrays. It's going to start accumulating these entries. And what's going to happen, we're going to build those up, we're going to process that, and then when it reaches a certain point, we're going to clear it out and start again. This is how we're going to kind of get specific regions over time, rather than these boxes changing every minute. And again, Claude could probably write something better than what I'm saying here. So I'm really specifying how I want the algorithm to work. So we want to keep an additional cursor. So that's like keep a record of the XY width height values, so the box, and keep changing it to get the maximums. So that will grow. So as the array builds up and things move, it will grow on, the coordinates will be growing on screen. And then what I'm saying in step 3 is once both width and height exceed 80% of the width and height, i.e. it's growing kind of too big and it needs to break out, then stop. Then what it will do is loop back over that buffer and get the median values for X, Y height and width and height and use that as the region for the whole segment, if that makes sense. And then it will zoom out for the last frame, set that to 0, 0 width height, so it will go and start again. And so keep processing the whole video like that. That is basically it. There's another prompt down here, and that's going to be actually applying this data. So I'll keep this context window because of what it's done here. I'm going to put this in plan mode. So what I'm actually going to do is get Claude to tell me if this is nuts. And I'm almost certain it's going to tell me, hey, you think you're smart, Chris, but I'm smarter. So I'm going to write, I want to. So because we're in plan mode, I'll declare more wishes than instructions. So let's send it that and see what it comes back with. Get Claude nice and big because we're going to probably need to do some reading here. This is the last complicated bit. So once this is done, then we're into use this data and try and apply the zoom and pan effect from this data. I've written a prompt for that. That's going to be doing a bit of magic with FFmpeg. The zooming and panning will be the tricky bit. If my assumptions in how I'm massaging this data as being usable are valid, then it will look great. If they're not, we'll be back to the drawing board. Along with that, I've also asked it to apply a motion blur effect. So it does as it does like a zoom or a pan. I want it to blur the frames because that is a relatively simple filter in FFmpeg. So I'm like, let's throw that in. Claude seems to just suck up everything I throw at it. All my doubts and fears and belief that it can't do anything have been completely thwarted by this project. There really has been nothing. All the bits I've been skeptical that Claude would be able to nail, it's done everything. So here we are at the pointy end of complicated things I'm asking for. We'll see what it comes back with. I don't actually think what I'm asking for here is too complicated. It's a bit of maths. This is the kind of thing a good software engineer will be able to code. So because I've written this in technical terms, it should understand that. Because I've written what I want to achieve, it should be able to understand it and come back and go, no, you're wrong. Let's do it like this. I could have probably just given this the first paragraph. So I could have probably just said, I want a new function that'll do this, and this is how I want to use this. And I may not have needed to write any of this. So depending on what it comes back with, that was either all a waste of time or not. This is the interesting intersection we're now at with AI, in that, is it worth trying to be smart anymore? Or is it better to just delegate everything? I like to think through some of this. If I don't think through some of these problems, I'm really offloading everything to AI. Some things I want to offload to AI, some things I don't. Okay, it's coming back. I've written something contradictory. The spec says minimum X and Y values for the cursor, but the example shows the cursor taking the max of X and Y. So I gave it an example. So cursor 2020, next frame 1080. Follow the text. The example is wrong. So it understands what I want to do, which I would think it would. So it's just spotted like, I've tried to go, hey, if you've got a cursor 2020 and the next frame you encounter is 1030, it should be going 1020, not 1030. As in this updated cursor would be 1020 like that. Whereas the width and height, it would push it out. It's picked up my mistake. More like a growing bounding box. I don't need to, it just wants me to confirm, understand. This is what I mean. Like, this is my experience now with Claude. Not only does it get the problem, it can also spot where I've made mistakes describing the problem. Writing a plan, let's have a look. Each motion event has exactly one region. The new subfunction will group consecutive frames into runs and collapse each run to a single representative frame, reducing noise and producing stable bounding boxes over time. That's it. It's written it better than I did. Files to modify, algorithms, smooth motion regions, operates on the already filtered merge list. Yes, exactly. I didn't specify that. It's got that correct. Per iteration, I'm not going to read this. I trust it. Otherwise, start a buffer run, buffer I, cursor, yep. In a loop. Okay. It's not a lot of data anyway. I mean, this is going to be, remember we're processing one video at a time. 25 frames a second, whatever that is a minute, probably like 1500 frames a minute. So if I'm going 10 minutes, 15,000 frames, it's going to tear through it. This is very, very quick math. So it doesn't need to be mega optimized. It doesn't need to be a mega optimized algorithm. It'll be over in nanoseconds. Complete the compute median. So the median I might change. This is the bit where I may have, that median is essentially saying keep the box that's kind of in the middle. So even though the motion's growing outside of the box, it's going to kind of keep it stable in the middle. For the shorts, I think this will be fine. Restructure normalized motion data. Change from a single pass loop to 3 explicit changes. So it's got some kind of refactoring it wants to make in mind. Fine. Important change. Import statistics. Wants that. Now on spec example, telling me I made a mistake again. And then verification. Yep, go. Imagine this will be fairly quick. I don't imagine this will take long to implement. Wow, 24 minutes in with me just explaining my prompts for changing data. But I hope this is helpful. Like, if you're interested in this stuff, it's the first time I'm doing this. So this is, you're hearing me think through this problem for the first time. It was a vague idea in my head of how could I use motion data. And most of what's happening here, I'm reacting to what's happening. Done. Okay. I'm not even going to look at it. I'm just going to process it. So what I'm expecting to see is just far less boxes. So we should see more stable boxes over a longer period. Simple as that. And then for the shorts, I guess those boxes need to be ideally changing every half a second to every couple or few seconds for this to generate some interesting motion. And ideally, if this gets tuned correctly, it would leave something zoomed in long enough for a viewer to go, oh, he's zoomed in on this text, or he's zoomed in on something I can just catch my eye on. So depending on whether this is too severe or too slow, we'll come back and tune the algorithms, would be the idea. Okay, so I've now applied this again. So it's going to have applied the first two algorithms, and then it's going to have applied this one as well, and we'll see what we've got. And this is easier. So a lot less motion data. That's exactly what I'd expect. I'm going to slow the speed down because that's realistic. It's not far wrong. That is not far wrong. So notice it's done that thing where it keeps going back up to the full width. So what I was thinking there, and I wrote that in the prompt, this is exactly what I wanted, was it would go, hey, apply this treatment, and then once you're at the end of a segment, zoom out. So it is working. Now this is a 4-minute video. Let's just stop it. I'm getting confused by the speed. You can see the time markings. You can see how frequently this is going to apply. So it's going to go full screen. It's going to zoom in here, 1 minute 46. Going to stay like that, and then it's going to go, that's over full screen. Then it's going to go here. Whoa, so these ramps are bad. Okay, this isn't going to work. So what this would do is it would go zoom in here, and then at the end it would go zoom out. And then that hard drop would immediately go zoom out, zoom in. Yeah, so all these hard drops, it's like a sawtooth. That's not going to work. So essentially what I need to do, I'm thinking what I could do is just say, for that zoom out treatment, rewind like, say 20% back. So that would bring it back here, and then you'd get a slower drop off back, or a slower zoom in to the new bit it's going to zoom in on. Because essentially, once it zooms out, you want it to hold zoomed out for a while. And also remember, because this has done the thing where it's growing, what's on screen is going to have been getting bigger before it reaches that point. So bringing this back a bit is not a bad idea. Now I need to describe this. So it works, like it's doing what I thought it would do, or what I asked for, but there will be a problem when this is applied to video. Data smoothing tweak, for this 2B. I think I'll do another part because this is going on a bit long. So we'll do the application of the data in the next part, and this will be a trilogy of motion detection. One change, having reviewed the treatment, which mostly looks good. For the calculation that sets the, how did they refer to it? Full screen values. I'll copy that in. Make this rewind 20% back through the accumulated buffer and set that value at the nearest motion event in the buffer array. Okay, stage its code. Not going to commit it. So what will happen is it will edit it, and it will be an untracked file, an untracked change. And then if it cocks up, we'll discard it, and then I might take a different approach. So hope that makes sense. And I'm just going at it automatically. It should have enough context of what we're doing to understand that requirement. And frankly, I think it would stop and ask me if it was like, what the hell are you talking about? It's got everything so far though. Now, one last thing I need to decide is how to do the zoom. So do I zoom to the smallest size of the width or height, or do I zoom to the max? Right, saying it's done it. So what I'm expecting now, if you look at this graph, this kind of drop off, all those peaks should go back. Render that again. This takes about 20 seconds. I'll pause. Okay, welcome back. So that's finished. This hasn't quite worked. So it's certainly stopped the drop-offs, the sort of sawtooth, that way for you on camera. But you can see it looks like it's almost lost some of the data. So something's wrong with that algo that it's created. So I'm going to stop this video here. I'm going to figure this out offline. There's no point waiting through this on this video. It's going to be very, very boring. May only take me a couple of minutes, may take a little bit longer. But I'll fix that up, and then in the next video, we will move straight to trying to get FFmpeg to process this and apply the zoom and pan. And I'll give you an update on where I land with this algo and explain what happened. So stay tuned. The next part could be pretty special if this works.